Hello everyone, I'm Manas Gupta. Welcome to my Google Summer of Code 2025 introductory video. This summer, I'll be working on an exciting GSoC project with beagleboard.org focusing on upstreaming and enhancing Linux support for Beagle Connect Freedom through wpanusb and bcfserial drivers. My mentors for this project are Ayush Singh, Vedant Paranjape, and Vaishnav Achat. I'm thrilled to contribute to this open source ecosystem and really excited. So, a quick introduction about myself. I'm a third year electronics engineering student at National Institute of Technology, Calicut, India. I'm an avid learner and I have a strong foundation in software engineering. I absolutely enjoy working at the intersection of hardware and software. I've previously worked on projects involving data science, embedded systems, and Linux based applications. So, the project vision is to make Beagle Connect Freedom usable as a fully featured IEEE 802.15.4 radio within Linux. Right now, the WPAN USB and the BCF serial drivers are incomplete and lack essential functionality to meet upstream standards. This includes missing driver operations like listen before talk and frame retries, hard coded channels and power configurations with no support for querying capabilities from the firmware. My goal is to fill these gaps, enhance the firmware to expose configuration data, and ensure full compatibility with both sub gigahertz and 2.4 gigahertz bands, ultimately supporting protocols like Zigbee. So, let's take a closer look at the system architecture of this project, which mainly involves three layers: the Linux kernel, the Zephyr firmware, and the hardware. On the left, we have the Linux kernel. The two drivers that operate here are WPAN USB for the USB based communication and BCF serial for the UART based communication. These drivers are responsible for interacting with the firmware and controlling the radio interface. A major upgrade I'm implementing is dynamic querying, where these drivers no longer rely on hard coded values but instead ask the firmware for real time radio configuration parameters like supported channels, power levels, and extended addresses. In the middle sits the Zephyr firmware, which acts as a bridge between Linux and the radio hardware. It implements the radio API, which will enhance to handle requests from Linux drivers. This API exposes config data and allows real time updates such as LBT, retry limits, scanning parameters, etc. Essentially, the firmware layer turns static radio behavior into dynamic, reconfigurable one. On the right, we have the hardware layer. The key devices here are the Beagle Connect Freedom, equipped with a radio transceiver that supports dual band communication, essential for protocols like Zigbee. The firmware manages IEEE 802.15.4 operations and sends commands to transceiver to change frequency, transmit data, more and more. The goal is to ensure the radio behaves correctly under Linux while supporting full interoperability with modern wireless stacks. So, here we have state of art hardware, the Beagle Connect Freedom, and the Beagle Play. The Beagle Connect Freedom has the Texas Instruments CC1352P7 ARM Cortex M24 chip inside, while the Beagle Play has the Texas Instruments AM625 ARM Cortex chips. Now, let's take a look at the current limitations. Here are the main problems I aim to solve. First, essential driver operations are just sketched out and need real implementation. Second, the firmware side doesn't yet expose these controls via radio API. Third, there's no way to read the device's permanent MAC address, which is crucial for networking in Linux. Finally, the Linux drivers are filled with hard coded values for power levels, supported channels, and etc. These need to be replaced by dynamic queries from firmware to support real world deployment and interoperability. Here's how I plan to execute the project over the summer. Right now, in early June, I'm focusing completely on the introductory video design documentation. From June 10th to 24th, I'll prototype the enhancements in the drivers and start integrating firmware support. By mid July, I plan to reach a major milestone, the midterm evaluation, with working firmware driver integration. Post midterm, the focus will shift to testing, expanding protocol features, submitting patch series upstream. By August, I'll be polishing everything with the documentation, final testing, and maintainer feedback before submission. Now, I would like to briefly explain my implementation plan. My implementation strategy has four key phases. First, the firmware capability exposure, which is implementing APIs like get extended addresses, get banned, get supported channels, etc., and hook these into these FIs radio API. Phase 2 is driver refactoring, and feature enhancement, which is replacing hard coded configurations in Linux drivers with runtime queries and ensuring the driver pathways are fully dynamic. The third phase is protocol feature expansion, add support for passive and active scanning, managing frames, and validate the IEEE 802.15.4 for upper layer compatibility. Also, the fourth phase is testing and upstreaming, set up CI, validate functionality, submit patches via B4, and respond to feedback and finalize the documentation. Now, the major benefits of these projects to both the developer community and the end users are enhanced maintainability, as the upstream drivers reduce the need for out of tree patches, making long term support easier. Improved interoperability, since dynamic configuration and Zigbee readiness allows broader Internet of Things adoption. Performance gains, as listen before talk retries and power control reduce latency and enhance reliability. Community collaboration, clean review ready patches for foster contributions and code quality. Future and scalability. The modular design here enables fast adaptation to new hardware and protocols. Thank you so much, guys, for watching my introductory video. I'm really excited to contribute to BeagleBoard this summer and collaborate with the open source community. If you'd like to follow my work, have any questions, or want to contribute, please feel free to reach out to me via email or GitHub. This is Manus Gupta signing off. Thank you so much.